When you look at our cities, they can feel, well, kind of chaotic, right? A jumble of history, planning, and maybe just pure luck. But what if I told you there's a hidden order to it all? A secret language written into the very streets we walk every single day.
I mean, think about it. You've probably experienced this yourself. One street is just packed with people, shops, it's this river of constant motion. Then you turn a corner and suddenly, nothing. The next street over is quiet, residential, almost like it's been forgotten. How does that happen?
Well, it turns out this difference is definitely not random. There's an underlying logic that's literally baked into the physical layout of our streets and buildings. The shape of our city actually guides our movement. And then, in a kind of feedback loop, our movement shapes the life of the city.
So what if we had a key to unlock that code, a way to actually understand and maybe even predict the social and economic pulse of a city just by looking at its map? Well, it turns out we do.
Okay, to really get our heads around the logic of a massive city, we're going to start small. Like, really small. We're going to start with something we all understand: a single house. So take a look at this. It's a pretty standard floor plan for a bungalow from the 1970s. And even in a simple layout like this, there's a built-in social logic. The way the rooms and doorways are arranged basically dictates how people move, where they're likely to hang out together, and where they can go to get some privacy. And here's where it gets really cool. We can actually map that social logic using something called a justified graph, which is what you see on the right. Think of it this way. Every room is a circle, and every doorway is a line connecting them. And the graph is set up to show how many steps it takes to get from the outside all the way into any given room. Notice how the bedrooms are way up at the top? They're topologically deep. That's a fancy way of saying they're the furthest from the entrance and they're dead ends. That's not an accident. That's how you design for privacy. So this whole method, this idea of translating physical space into a network of relationships, it actually has a name. It's called space syntax. It was developed back in the 1970s, and it's become this incredibly powerful tool for analyzing how the layout of any environment, from one room to an entire city, shapes our social lives. And what's so amazing about this kind of analysis is that it proves that even a tiny, tiny change in the physical layout can have a massive impact on the social dynamics of a space. Okay, now watch what happens. The new owners of this house made a small renovation. They just knocked down 2 walls. And look at the graph on the right. The entire network has been rewired. The kitchen is suddenly way more central, and one of the bedrooms isn't a private dead end anymore. It's now a path to a new winter garden. Just like that, the social logic of the house has been completely rewritten. All right, so that's a house. Pretty cool, right? But now, let's blow this whole idea up to the scale of an entire metropolis. Because believe it or not, the exact same principles apply. When we look at a city, space syntax asks 2 really fundamental questions for every single street. First, how easy is it to get to this street from every other street in the city? That's what we call its to-movement potential, or its closeness. And second, how likely are you to pass through this street on your way to somewhere else? That's its through-movement potential, or its betweenness. So the process, in concept at least, is pretty simple. First, you map the city's entire street network. Then you use computers to calculate those to and through potentials for every single street segment. And finally, this is the magic part, you visualize all that data on a map. And when you do, it suddenly reveals this hidden functional skeleton of the city. So, we've got these incredible, colorful maps of lines and graphs, but who cares, right? Why does any of this matter? What does it actually tell us about our lives? Well, this is where it gets really mind-blowing. Decades of research have shown that these spatial patterns correlate incredibly well with all sorts of real-world things. They predict where people are most likely to walk, where shops and businesses will pop up and succeed, and they even correlate with things like land values and crime patterns. You want a perfect example? Trafalgar Square in London. It used to be a glorified traffic island, isolated and totally underused. A space syntax analysis showed that if they just closed one side to traffic, it would stitch the square right back into the city's main pedestrian network. So they did it, and it completely transformed the square into the vibrant heart of London we know today. See? The layout isn't just a container for life, it actively generates it. And this power is exactly what experts are talking about. As Professor Michael Batty says, it gives us a real language to describe how spaces work and, well, why some designs are a success and others are a total flop. It helps move urban design from being based on just pure intuition to being based on actual evidence. And that's really the biggest takeaway here.
Space syntax isn't just a tool for analyzing cities that already exist. It's a powerful instrument we can use to shape our future. I mean, think back to that Trafalgar Square example. By understanding this hidden logic, we can test new designs before they're even built. We can ask questions like, what happens if we add a new bridge right here? Or how will this new park connect these two neighborhoods? We can actually design urban spaces that we know will be safer, more integrated, and more successful for everyone. So the next time you're walking around your own town or city, try to look at the streets with new eyes. Don't just see the buildings and the roads, see the network. See the connections and the disconnections. And ask yourself, what's the hidden logic of your city?